Why does anyone want right-brain computing anyway? Maybe this can be compared to the question, why does anyone go to an expert? You go to experts, because you hope that they can address your problems. And you are not talking about simple problems, because you could handle those yourself. You are talking about complex problems that require their expertise. You want to take advantage of their judgment and reasoning skills, their experience, their training, that allows them to observe the situation and make expert judgmental decisions about how to proceed. So, what are some characteristics of complex problems? Complex problem sets are likely to have numerous parts. There may be resource allocation decisions where some of the demands are in conflict, and the objective is to find the best overall allocation of resources at the most appropriate time. There may be temporal, time and distance impacts associated with potential solutions. There may be dynamic interactive aspects. There may be adversarial or competitive components to the problem space. Stress may impact how influencing factors are considered. There may be legal, ethical, and emotional aspects associated with the problems, and with the potential solutions. There may be tactical and strategic concerns, solve it now, but consider the future. There may be risk and reward consequences. There may be cost versus schedule issues. There may be direct and indirect consequences for the decisions and the actions. In some cases, the expert decisions are point decisions, as in initiating a plan of action, while in others, there may be continuous adaptive control actions, as in continuously adapting the plan in response to changes in a real-time scenario. Human experts use their judgment and reasoning skills to solve the complex problems. Unlike digital computers, humans use their analog computers, their brains, to process all parts of the problem space together. They mentally integrate and balance the interrelated influencing factors, and derive their decisions and actions. Another way of saying this is to say they are collectively processing weighted, or valued, information. This balancing act has been termed a cognitive cycle, where the human is considering or contemplating the solution. This value-based interpretation of information has been considered a right brain process, compared to the left brain, sequential, rule processing. Historically, it has been the human's ability to apply judgment and reasoning that has separated human responsibilities from computerized systems, and limited what can be automated. Now let us look at machines. We build machines to do things faster than what can be accomplished by humans. We build machines to handle more weight. We build machines to increase quality with precision and accuracy and to avoid human error. We build machines to keep humans out of harm's way. And we build machines to go where humans cannot physically go, because of size and environmental constraints. So where does that leave our experts? Humans, the experts that deliver repeated solutions to similar problems in their domain, are slow, weak, error-prone, and expensive organic machines. In many cases they are biased toward solutions they are comfortable with. They know only what they know, and neither the experts, nor their clients know what they don't know. Sometimes the experts are influenced by outside parties, that may not have the expert's clients in mind when they attempt to influence the decisions and actions of the expert. Some doctors that push a certain drug may be an example. Back to our original question, why does anyone want right brain computing anyway? There are two overriding reasons. First, the consumer of the expert behavior wants to know that the decisions and actions are the best possible. With humans, you are just hoping that they are doing the best possible job. You are hoping they are not distracted. You are hoping they are attentive to your needs. You are hoping they are keeping up with their necessary skills. You are hoping they are fast enough in their decision-making to respond as demand for their skills increase. The second reason is one of cost. If you are on the receiving end of the expertise and are paying for the service, you want to control costs. If you are in a competitive situation as a supplier of expertise, you want to keep your base costs to a minimum, and you find value in being able to replicate, and potentially mass-produce the expert behaviors to increase your profits and reduce your liability for human error. Even if you are not replacing your human experts, there is value in augmenting their behavior to ensure they are not making foolish and potentially expensive mistakes. And if you are the consumer, maybe you have noticed. Humans are in a state of information overload. The more information they are exposed to, the more opportunities there will be where critical information is ignored. Computerized systems can handle specific jobs more efficiently than humans, because they do not have to handle all of the social issues that demand the attention of humans. One approach to right-brain computing is CumpSim's Keel technology. If this approach is used, then the Keel-based systems can provide 100% explainable and auditable behaviors. This has two benefits: the operational policies that describe the delivered behavior can be reviewed, so the consumer can see exactly how the decisions or actions were made. This has a similar value for the provider of the expert behavior. As new information sources are made available, they can easily be integrated into the solution. As new tools are made available, or if new knowledge needs to be integrated into the solution, the changes can be made quickly. If any problems are encountered, they can quickly be reviewed and corrected. And if the revised policies need to be distributed to a broad audience, they can quickly be delivered. Compare this to re-educating a population of human experts, where this may take years. So whether you are a consumer of expertise or a provider, right brain computing will define the future.